Okay, good morning, everyone. Thank you very much for being here, for selecting this track when there are a very interesting session in the next room. And especially when I have in the title some words like operational, transactional. These seem words from the last century. We are used to handle transactions for over more than 30, 40 years. So we are doing that very well with traditional SQL databases. So what is behind Trafodion? Trafodion is an open source project to deliver enterprise-class SQL-on-Hadoop. So it is a database, but we think it is not a normal normal database that you can have in your traditional data centers. So let me explain what I am going to show you right now. In this agenda, we are going to see what is the current database landscape, what we have right now, what are the tools that we have to handle all the type of data, and also a prediction, where is the big data world moving, why the transactions are so special, why we have problems handling transaction in Hadoop when we can handle them perfectly in traditional SQL engines. What is HP Trafodion, and what is the technology, what are the innovations behind Trafodion. Also, we are going to have a short review of use cases. And one of the most important points that I put on the last is that Trafodion is an open source project. So you can download it, you can use it, you can try it, you can contribute it. So I think my first request to you is come to our homepage and try it. That would be the most important for me and the most important goal for me in this session. So what is the current database landscape? So probably you have seen this type of report. This is the data platform landscape. There are so many databases, data platforms, so many as stars. Aquí diríamos hay tantas bases de datos como botellines, yo creo. There are so many. Why we think, by the way, Trafodion is over there on the top. Why we think Trafodion is a different type of database? We have so many type of database with so many characteristics. So if you allow me a little bit of oversimplification, we have 4 groups. We have the traditional SQL databases. They are very nice in handling transaction. They are ACID compliant. You can use full SQL. So, and we have been working, we know them very well. We have been working with databases for more than, this type of databases for more than 30, 40 years. We also have NoSQLs, where we have a very good introduction and view from Norberto. They are open source, in contrast to many of the SQL databases that we have, traditional SQL databases. They can scale without limit. They don't have problem with high availability. And they also can handle unstructured data, which is very important. We also have NewSQL. NewSQL are databases that are full SQL. We can use all our existing scripts, skills, and so on. They can also scale, but they also have problems in terms of they are mainly proprietary. And they are not based in what is currently almost getting to a standard for storage thing that it is HDFS. And finally, we have Hadoop. Hadoop is not even a database. But with Hive and HBase, we are able to get some SQL-like abilities to handle data. So all of these type of databases, of data platforms, they have a lot of advantages. They have very nice features to handle certain type of workloads, but you can't use only one type of this platform to handle all type of workloads. Traditional SQL normally doesn't scale well, doesn't struggle when they have to work with semi-structured or unstructured data. You miss a lot of SQL capabilities when talking about normally NoSQL. Please allow me a little bit of oversimplification. And NewSQL is mainly proprietary, and you have to move a lot of data when working with them. And we have Hadoop. That Hadoop doesn't have full SQL capabilities, doesn't guarantee data integrity. So okay, there are different platforms. Each has a perfect match. So what we can do is, okay, use each platform, the right tool for the right job. That will come out to this slide. So we can use Hadoop to what it's good for. You can use Hadoop for operational, real-time analytics. You can use also Hadoop for interactive, data visualization, data exploration, for non-interactive, like data mining, data preparation, batch work. So many of the session today and tomorrow is going to be around data warehousing and analytics. So we can use Hadoop for all of these type of workloads. And we can still use traditional SQL databases for transaction. Because Hadoop doesn't provide us the data integrity, data consistency, the transaction support that we need for everyday operation that we have every time we go shopping, every day that we get cash from an ATM, or we enter in our offices and show our badge. So we have transaction everywhere, and we have been dealing with that very nice. But we cannot do it with Hadoop. So okay, doesn't matter. We use Hadoop for what it's good for, and continue to use it traditional SQL engines for transaction. But if we do so, if we use the right tool for each job, we could have a similar picture like that. We could have our traditional databases for transaction, for operations, but we want to make analytics on top of that. So we move all the data to the Hadoop cluster or to the NoSQL cluster, but also we want to analytics in really real time, next best action, next best offer. So we need also in-memory analytics. So probably you get the picture. We are started to moving a lot of data from one side to another, replicating terabytes of information, and this is not easy, this is expensive, and overloads the network. So it may be obvious, but big data is hard to move, so because it's big. So when we move such amount of terabytes, petabytes, we are going to have problems. And there is a fair chance that something will fail. You probably got the gut feeling when you see such an amount of suitcases, when a lot of problem or bump, some suitcase is going to fall down. So when you move such a big data, the data that arrives at the other end is not current data. It's data from yesterday or data from the previous week. So you are missing information. You also have problems copy and replicating data. So you probably start to think about data quality and data consistency problems. And this is the current landscape that we have today. And now a type of prediction. Nowadays, it's not a prediction anymore. I think it's a current trend and a stoppable trend. And it is that Hadoop will be the platform to rule it all. This is not my prediction. I am not so clever. This is the prediction of many companies, many analysts, and also the prediction for Doug Cutting. Doug Cutting, in the Strata conference of the last year, made this quote. Please let me to read something aloud. Transactions were something that were long thought to be out of the scope of this type of platform, of Hadoop. And you need, for example, at the same time to make sure that the money is in one place or in the other, not in both, not in nowhere. So I think that, coming to the end, so I think the prediction we can make here is that it's inevitable that we will see just about every kind of transaction to be moved to this platform, even online transaction processing. So why are transactions so special? Why handle? This is I wanted to say a new technology. This is a mature technology, but we have transactions for over more than 40 years, and the history of Hadoop is not so long. Why can't Hadoop handle with this type of workloads when traditional SQL engines can do it perfectly without any problem? What are the characteristics of traditional SQL engines? Traditional SQL engines are designed to handle a lot of customers, a lot of clients, accessing to the same data concurrently with very low latency times, all at the same time, and maintaining one of the main important things of all of these characteristics, maintaining data integrity. This is the most important requirement of this type of application. So Hadoop doesn't have any problem with high availability, doesn't have any problem with scalable, doesn't have any problem with handling multi-structured data. But when it comes to the second one, to the ACID, to ensure data consistency, data integrity, here is what we can see the Hadoop limitation. So let me make a quick overview of what this ACID compliant means. So this type of characteristics, ACID, we are going to see right now what ACID means, but sure many of you already know, is basic when you want to handle transaction data. ACID is the acronym of atomicity, atomic, consistency, isolation, and durability. To give a brief summary, what it means is when you make a transaction, and the system that handles the transaction, you want to be sure that you make the whole transaction or do nothing. Don't give me half results. I need everything or nothing. I need to be sure if something has to work or doesn't work. No, don't give me half results. But it's better if we see that in two examples. This is a typical bank transfer example that everyone can see in any database book. When you transfer £50, 50 euro from one account, account A to account B, you want to be sure that you get the money from one account and put the money in the other account. So in terms of the ACID principles, you shouldn't take money from A without giving it to B. Money isn't loss or gain. No matter how many users, no matter how many sessions we have in the database, other users, other sessions doesn't have to interfere with each other. And if the money gets to account B, no matter what happens to the database, if it crashes or whatever, the money still is in account B. Doesn't go back to account A or disappear, whatever. But this is a very boring example, so I found a funnier example. This is what happened in Samoa. Samoa, two little islands in the Pacific, decided in 2009, so not very far away, to switch driving from the right side of the road to the left. I invite you to read the story in the New York Times. It's a very funny story. Imagine we could do that in SQL, thanks to Michael Swart for this example. Imagine we can do it like a transaction. Update roads, traffic direction from right to left, update traffic lights to left, and update intersection to left. Imagine if we don't handle this on an atomic transaction. We could set roads to left without changing the traffic lights or the intersection. That would be a chaos. So we have to be sure that we execute everything at once, all or nothing. I don't want to update the traffic lights without updating the traffic direction or the intersection. Otherwise, that would be a chaos. And this is the type of situation that Hadoop cannot handle right now. And this is where Trafodion is going to fill this space, providing SQL transaction protection and ACID compliant on top of Hadoop. What is Trafodion? Trafodion is an open source project sponsored by HP Labs, that use Hadoop, use HBase, so you can still use Hadoop for all the type of work that you are using right now. So you continue to use Hadoop for platform for everything. Trafodion is open source. You can download it. You can contribute to it. You can use it with any type of license. And leverages the flexibility, scalability of Hadoop. And on top of that, we add the features of traditional SQL that we have seen so far. Full function NC-SQL, distributed ACID transactional properties. This is very important because in traditional SQL, database, we have everything in one node, in one small cluster, so everything is contained in itself. When we come to Hadoop, we have several nodes, several regions, several processes, so it's very difficult to ensure transaction where data is spread all over the cluster. And we developed so many efficiencies of top of Hadoop to make real-time transaction possible on top of Hadoop. And this is the result of more than 20 years investment of HP in traditional, in SQL databases, and how to bring that together with Hadoop. By the way, Hadoop means transaction in Welsh language. So I still have to find which of my colleagues have a girlfriend in Cardiff or in any other city in Wales. So what are the features of Trafodion? The features of Trafodion is that it's complete full function SQL. You can use select, insert, update, create table, create views, join, merge, whatever you are used to do it with a normal database, you can use it with Trafodion. Trafodion provides the protection, so you can be sure that when you make a transaction, Trafodion takes these statements and provides the data integrity, data consistency on top of Hadoop, even if Hadoop doesn't provide this type of feature. It's efficient. Why? Because you can ensure data integrity. Every time you access to a database, you lock the entire database, so there's no problem with conflicts with each other, so you lock the entire database, and you are going to have ACID characteristics, but this is not going to perform. So we develop low latency read and write transaction, so we can handle we can provide low latency times for a transaction. It is interoperable. We provide ODBC and GDBC drivers to connect with existing application, and we can also even federate data from Trafodion to Hive and HBase without loading the data into Trafodion. So you can use full SQL statements and query information that you have in HBase and Hive. And of course, on the right side, you have all the properties that you have when you use Hadoop. It's scalable, high available, it's open, and of course, there are thousands of applications on top of Hadoop that you can use and leverage the large Hadoop ecosystem. So to give you a brief overview, although Trafodion leverage HBase, what are the benefits, what are the additions that we added to HBase? HBase is a column database with key value pair. On top of that, Trafodion provides a relational schema. So you, as I said before, we can create table, create views, delete, insert, whatever, without taking advantage of the SQL skills that we already have. In terms of physical layout, it's very similar, but we optimize making some space-saving column encoding. In terms of column volumes, in HBase, you have all together in an interpreted array of bytes. When we come to Trafodion, we explicitly define and enforce data type. That saves a lot of time, a lot of money, making your application dealing with the quality of data and the type of data. So when you insert data into Trafodion, you ensure that this data is a string, this data is an integer, or whatever. So you avoid making some type of comparisons or checks when dealing with data with Trafodion. Of course, the main characteristics about ACID, HBase only provides atomicity in a single row level. We are able to provide transaction support for multiple SQL statements, multiple tables, multiple rows, and we are able to ensure data integrity in those terms. In terms of API, HBase has a very low-level API. We provide, on top of that API, because we use HBase API, we provide a full-function SQL as any other database in the market. And in terms of index, to speed up a little bit, HBase only provides with a one row key. With Trafodion, you can define secondary key columns, how they are defined, so you can speed all your queries, even if you don't know which is the row key, you can create secondary indexes. So what are the benefits when we use Trafodion on top of Hadoop? You have the best of both worlds, of Hadoop and traditional SQLs. You have complete ANSI SQL. You can reuse your people, reuse your skills, reuse your scripts. It guarantees transaction. So this is the main goal of Trafodion, to be able to handle this type of transaction. It is efficient. As I said before, it doesn't make sense to lock the entire database to ensure data integrity. Of course, we could do that, but that wouldn't perform. So we make a lot of efficient that we are going to see right now to be able to deliver low latency response time to transaction. It is flexible. We can leverage the flexibility that is behind HBase and Hadoop. And of course, we also are very concerned about how to connect Trafodion to the rest of the world. So we provided ODBC, GDBC access, and in the future releases, also .NET. And it is open. As I said before, it's an open source project. Let's take a look to what are the technology and what are the innovations that are behind inside Trafodion. As I said before, we leverage some core modules of Hadoop. As you can see in the picture, we use HDFS to store all the data of the database. We also use HBase. We use Zookeeper for high availability, and we also use Hive. Using these core modules, we build on top of that, and we provide a distributed transaction manager, which we are going to see right now, ensure that no matter how your data is spread in many, many nodes, as is usually in a Hadoop cluster, you can ensure that the transaction is handling data in a consistent and you have data integrity. On top of that, we have an SQL compiler, an optimizer, and we provide the client services for the ODBC, GDBC drivers. To understand a little bit more how this, all these pieces work together, the Hadoop is a software that is in 3 levels. We have the client levels, where the ODBC, GDBC drivers allows you to connect to the database. The SQL engine, the second level, the level in the middle, provides the abstraction to provide you a relational schema. So you work as on a normal database, but behind, in the third layer, we have the storing engine. You are really accessing data that you have in Hadoop, in HDFS. So with this SQL layer, we are providing the necessary abstraction you need to work with Hadoop data as similar as you are working with your SQL. In this picture, we can see how a SQL statement is handled. So when the client issues a transaction with the DCS, with the database connection service, we receive the connection and we assign a master process. The master process is going to be in charge of the whole execution of the statements from the client and ensure that this statement is going to have the necessary integrity and optimize in terms of performance. How does this going to be done? With the compiler and an optimizer, the CMP, the master gives the query to the compiler, so we get which is the optimal path, the optimal execution plan, so we can parallelize, imagine a whole transaction, how we can divide this transaction in several pieces, so we can first ensure data integrity, and second, give the best response times. When we have the right execution plan, we give all these individual plans to the executor server processes, which are going to access directly to the HBase tables if we have several execution paths. If our statement is a simple statement, read or write any single row, we can also access directly from the master to the HBase. When we have a very complex statement, we have the DTM, Distributed Transaction Manager, which is going to ensure that the transaction is handled along all the clusters with the necessary data integrity and consistency of the data. So here's one of the areas where we have a lot of improvements on top of Hadoop and a lot of innovation. When we get the query statement on to the SQL normalizer gives transform the query into its canonical form. So we are able to see if we can divide the SQL statement in several subqueries. This is now the process of the SQL analyzer. So imagine we want to join tables A, B, and C. We can do it in several forms. We can join A and B and then C. We can join A and C and then B, or B and C and finally join A. This is the work of SQL analyzer to give to the plan generator all the possible paths of executing these tasks. Now we have to decide which task is going to be more, we're going to have less response time, which is more optimized, and these are the goal of all the three boxes that you have on the right. Table statistics, cardinality estimator, and cost estimator. They are taking statistics from the whole database. They have information how the data is spreaded. So, you know, in Hadoop, the information is replicated in several nodes, in several regions in HBase and so on. With this type of boxes, we know where the data is, how the data is disseminated along all the cluster, and how much with the cost estimator is going to cost in terms of I/O, input-output operation, and so on. The type of queries that are coming out from the SQL analyzer. So we optimize this query so we get what is the best execution plan to access to HBase to provide the low latency times and ensuring transaction protection in top of Hadoop. So when we have this execution plan, the SQL statement is divided into several operators. So we're sure that we can make some parallelisms, so we can access some table, then joining them. We could have partitional parallelisms, operator parallelisms, pipeline parallelisms. So we have a lot of work done in this type of optimizers. So when you execute a query on Hadoop, you get really real-time transaction responses, so you can get data as soon as possible, so you can handle with this type of transaction. This is one of the main characteristics of Trafodion. So to ensure that on top of Hadoop, you got this type of latency times. The second one is the Trafodion distribution protection. Doesn't matter which type of operation you have. For example, the first one, multiple rows, inserts, updates, deletes in a table, or when you are handling several tables, A, B, and C, or several regions in different nodes. DTM, the Distributed Transaction Management Protection, ensures that you are handling data in a consistency and ensure integrity on all your Hadoop environment. And finally, about the features that Trafodion provides is the availability to integrate external Hadoop tables. From Trafodion, using full SQL, you can query Hadoop, HBase, and Hive data without loading this data into Trafodion, without giving them a fixed structure that probably we don't know at the beginning, but we can query them from Trafodion, so you can still use full SQL. So what are some of the use cases that you can use with Trafodion? Okay, at the beginning I say that Trafodion is a database on top of Hadoop for transaction. And we have been dealing with transaction for more than 30, 40 years. So you can use Trafodion in thousands of industries, in thousands of use cases. So all the type of work we have been doing for the last 30, 40 years. We can use Trafodion anytime we want low latency, high concurrency, when we need ACID properties, data integrity, and also when we used to when we want to use multi-structured data. So there are a lot of industry because we know that for hard. We know where we can use a relational database. All of these use cases, we can use Trafodion. Of course, if you have a small transaction SQL database for dealing with some type of transaction, very small, it doesn't worth to make the switch to Trafodion. But if you are starting to having troubles with your SQL database because it is getting bigger, or if you want to handle structured, semi-structured, unstructured data, and also to want to make analytic and operational workload in the same platform, Trafodion will be your perfect match. Then this slide is only one example of a use case. Imagine you want to integrate structured, semi-structured, and unstructured. The type of data we see on the right is typical in all type of catalog. Amazon, eBay, and so on. You have some type of structured data, item ID, description, cost, price. We also have semi-structured because it depends of the item. We have several properties for TVs, and other properties for books, and also we also have unstructured data, images, review, Twitter data, and so on. With Trafodion, you can handle in one platform all this data, and with a single SQL query, make this type of integrating of this type of data. And finally, I want to sum up with what I think is one of the most important features of Trafodion. Trafodion is an open source project. As an open source project, you can have everything that you have in Hadoop, HBase. You can get the code in GitHub. You can track any type of defects in Launchpad. You can have all the documentation in the MediaWiki. In the next slide, you're going to see the web page. So everything is following the open source best practices. So we are committed to open source and to provide you with all the information. And our goal is, and we are already starting to build it, is to build an open source community. You want to try it? Go to our webpage, trafodion.org, download it, use it. It's simple to install. You can. One thing that I missed to mention is Hadoop and Linux distribution neutral. You can use whatever Linux distribution. You can use whatever Hadoop distribution. Trafodion is going to work on top of that. And also, as an open source project, we are also open to get help from any of you, from any contribute member that wants to add his knowledge to our platform. So the last slide from my side is I invite you to come to our webpage. It's this one, when you can download the package, you can access to them documentation, you can also see what has the releases, the next features, and also how to contribute to the project. As a summary, Trafodion will release Trafodion as a beta release in June. We came out with another release this October, and we are planning by the end of January with the first production version of Trafodion. So I hope you enjoyed this presentation. I hope it brings some value to you, and of course, I am open to any type of question. Thank you very much.